DC motor operating modes. In the previous video, we have seen the basic characteristics of the DC motors, separately excited DC motor as well as series motor. The link is given in the description. Please go through it. Now we'll see the operating modes of a DC motor. In variable speed applications, the DC motor may be operating in one or more modes. The first mode is a motoring. The arrangements for motoring are as shown in this figure. This is regarding separately excited DC motor and this is regarding the series motor, where we have a condition that Eg is less than Va. Here also Va is the supply voltage. Both armature current Ia and field current If are positive. The motor develops the torque to meet the load demand. Mode 2 is regenerative braking. The arrangement for separately excited DC motor and series motor are shown here. The motor acts as a generator and develops an induced EMF voltage, that is Eg, and which is greater than Va in this case. The armature current Ia is negative and field current If is positive in this case. The kinetic energy of the motor is returned to the supply. A series motor is usually connected as self-excited generator. For self-excitation, it is necessary that the field current adds the residual flux. This is normally accomplished by reversing the armature terminals or the field terminals. Here we reversed the field terminals. In the motor case, the F2 is connected to A1 and here the F1 is connected to A1. Mode 3 is the dynamic braking. The arrangement, this is separately excited DC motor and this is series motor, similar to those of the regenerative braking, except that the Va is replaced with braking resistance RB, let it be, that B. The kinetic energy of the motor is dissipated in the braking resistance RB. The fourth mode is plugging. Plugging is a type of braking. The connections for plugging are as shown for separately excited DC motor and series motor. The armature terminals are reversed while running. The supply voltage Va and the induced back EMF Eg acts in the same direction. The armature current is reversed, thereby producing a braking torque. The field current is positive. For a series motor, either the armature terminals or field terminals should be reversed, but not the both. These are four different modes of operation of DC motor in variable speed applications. Now, four quadrants. This figure shows the polarity of the supply voltage Va, back EMF Eg, and the armature current Ia for separately excited DC motor. In the quadrant 1, that is forward motoring, armature voltage Va, back EMF Eg, and armature current Ia are all positive. The torque and the speed are also positive in this quadrant. This is forward motoring mode. During forward braking, that is in quadrant 2, the motor runs in the forward direction and the induced EMF Eg will continue to be positive. For the torque to be negative and the direction of energy flow to reverse, the armature current must be negative. The supply voltage Va should be kept less than Eg, that is back EMF. In third quadrant, the reverse motoring Va, Eg, Ia are all negative. The torque and speed are also negative in this quadrant. To keep the torque negative and the energy flow from the source to motor, the back EMF Eg must satisfy the condition that Va is greater than Eg in magnitude. The polarity of Eg can be reversed by changing the direction of field current or by reversing the armature terminals. During a reverse braking or fourth quadrant, the motor runs in the reverse direction where Va and Eg will continue to be negative. For the torque to be positive and the energy to flow from the motor to the source, the armature current must be positive. The induced EMF Eg must satisfy the condition that Va is less than Eg in magnitude. This is regarding the DC motor operating modes in variable speed applications. If this video is useful, please like, share and subscribe.